Welcome to MRL. In solid mensuration, we have already learnt very important solid figures. Now here we have one more solid figure known as frustum. Now what is a frustum, or a frustum of a right circular cone? Now frustum is a solid figure generated when a right circular cone is cut by a plane at a certain height parallel to the base of the cone. So let us understand this statement. We have a cone here, and this cone is cut by a plane at a certain height parallel to the base. When the plane cuts the cone at a certain height, a small cone gets cut off, and what remains behind is the frustum. So this is the frustum. So from a cone we get a frustum when a small cone is cut at a certain height parallel to the base, and that is what is frustum. So let us understand the features of a frustum. A frustum has two circular bases. So it has got one circular base here and the second circular base. So it has got two circular bases, and the bottom circular base is of radius capital R, and the top circular base is of radius small r. Now it also has a curved surface. So therefore, if you look at a frustum, it has total three surfaces. That is the curved surface, the circular base, and the circular top. Then so that is what I have shown in the figure here. Now it has got a vertical height. The distance from the center of the circular base and the center of the circular top is what is called as the vertical height, and is denoted by h. So therefore the perpendicular distance between the centers of the bases is vertical height. So h is the vertical height here. It also has slant height. The distance between corresponding points on the circumference of circular bases is called as slant height. So if you take a point D here on the circular top and a point C on the circular base, then the distance CD is called as the slant height, denoted by small l. Now the relation between L, H, R and R. Now R is the radius of the top circular surface, capital R is the radius of the circular base, L is the slant height, H is the vertical height. So let us understand the the relation they have. Now if you take this triangle here, this is the triangle DEC. L is the slant height, EC is the R minus R, because the bottom circular base is having capital R radius, and this is small r. So EC will be R minus R, and the height DE is H. The same triangle I have taken here. So DE is H, DC is L, and EC is R minus R. So please understand, EC is R minus R because the total length is here, that is R, and this is R. So R minus R will be EC will be R minus R. Now by applying the Pythagoras theorem, we get L square is equal to H square plus R minus R whole to square. L square is equal to H square plus R minus R whole to square. So this is a relation, a very important relation, because we can find out one unknown when the other values are known to us. So that is what is the important relation between L, H, R and capital R. Now the other important formulas are the curved surface area of a frustum is pi L in the bracket R plus R, capital R plus small r. Then total surface area of a frustum is equal to the curved surface area plus the base area plus the top area. Now therefore total surface area is equal to the curved surface area, which is pi L in the bracket R plus R, base area is pi capital R square, and the top area is pi small r square. When we add all these three, we get the total surface area of frustum. Now the volume of frustum is 1 by 3 pi h. 1 by 3 pi h. H is the vertical height, in the bracket capital R square plus product of capital R and small r plus small r square. That is what is the formula for the volume of frustum. We also can find the volume of frustum by the relation 1 by 3 h in the bracket capital A1 plus capital A2 plus square root of A1 A2, where A1 is the area of the circular base and A2 is the area of the circular top, and we know how to find out the areas of circular base and circular top. Now the similarity of triangles of cone and its frustum. Now if you take the cone ABC here, then the cone is ABC and the frustum is we have a frustum also here. So now if you look at the triangles here ADE and AFC, if you look at the triangle ADE and AFC, then we find their corresponding angles are equal, because this is 90, this is 90, this is a common angle, and automatically the third angle becomes is also equal, and therefore by correspondence of angles, or because they are equiangular, the two triangles ADE and AFC are similar. Because they are similar, their corresponding sides are proportional. That means AD upon AF is equal to DE upon FC is equal to AE upon AC. So please remember this property, and it is very useful in calculations on examples related to Frustum. So these were a few important formulas of Frustum, and also a few important details of Frustum. So remember this and use them for calculations or solving the examples on Frustum. But again, we will be learning the derivation of these formulas as in a separate session of learning on Frustum. Okay, remember this much and try to remember the formulas. The formulas are very important for you to remember, because the formulas are required for calculations on examples of Frustum. Thank you.